Numerical problems. Question. A 70 kg man runs up a long flight of stairs in 4 seconds. The vertical height of the stairs is 4.5 meter. Calculate his power. Data. Mass of the man is equals to m is equals to 70 kg. Time taken is 4 seconds. Height of stairs is h is equals to 4.5 meter. We have to calculate power. Solution. We know that power is equals to work done per unit time, and work done is equals to mgh, because work done is equals to F dot D, force into displacement. Here force is weight of the body. Force is equals to weight of the body, that is equals to mg, and displacement is height h. Putting values of mass g and h and t, and after solving we get power is equals to 771.5 watts. Question. A body of mass 2 kg is dropped from a rest position 5 meter above the ground. What is its velocity at height of 3 meter above the ground? Mass of body is given, that is equals to 2 kg. Initial velocity of body v1 is equals to 0 because that body is dropped from rest position. Initial height is h1 is equals to 5 meters because body is dropped from the height of 5 meters. And final height is h2 is equals to 3 meters. We have to calculate velocity at height 3 meter above the ground, that is equals to v2. Solution. Loss of potential energy is equals to gain in kinetic energy because body is dropped from certain height and there is loss of potential energy, and that loss of potential energy is equals to gain in kinetic energy. Using formula, loss of potential energy is equals to mg h1 minus h2, that is equals to gain in kinetic energy half m into v2 square minus v1 square. Putting values in this equation, we get v is equals to 6.3 meter per second. Question. A man pulls a trolley through a distance of 50 meter by applying force of 100 Newton, which makes an angle of 30 degree with horizontal. Calculate the work done by the man. Here displacement covered is equals to 50 meter and applied force is equals to 100 Newton and angle is 30 degree. We need to calculate work done. Solution. As we know that work done is equals to force into d cos theta, and putting values of force, displacement and theta, and after solving we get work done is equals to 4330 joules. Question. The roller coaster car starts its journey from a vertical height of 40 meter on the first hill and reaches a vertical height of only 25 meter on the second hill, where it slows to a momentary stop. It traveled a total distance of 400 meter. Determine the thermal energy produced and estimate the average friction force on the car whose mass is 100 kg. Data. Total distance is d is equals to 400 meter and height h2 is equals to 25 meter and height h1 is equals to 40 meter and mass is equals to 100 kg. Solution. The thermal energy produced is equal to loss in mechanical energy. So thermal energy is equals to delta E is equals to minus into mg h2 minus mg h1. Putting the values and after solving we get thermal energy is equal to 1,47,000 joules. Work by friction is equal to change in mechanical energy, and work done is equals to minus F into D, that is equals to minus thermal energy, that is equals to loss in mechanical energy, and from here we get frictional force is equals to thermal energy divided by distance, And by dividing both the terms, both the values, we get frictional force is equals to 370 Newton. Question. A man whose mass is 70 kg walks up to the third floor of a building which is 12 meters above the ground in 20 seconds. Find his power in watts and horsepower. Data. Mass of man is equals to 70 kg. Height of building is equals to h is equals to 12 meter. And time taken t is equals to 20 seconds. We need to calculate power in watt and power in horsepower. Solution. Power is equals to work done per unit time. Work done is equals to mgh, and putting values of m, g, h and t, and after solving we get power is equals to 411.6 watt. We need to calculate power in horsepower, and we know that 1 horsepower is equals to 746 watts, and power is equals to 411.6 divided by 746, that is equals to 0.55 horsepower. Question. To what height can a 400 watt engine lift a 100 kg mass in 3 seconds? Data. Power is equals to 400 watt, mass is equals to 100 kg, and time taken is 3 seconds. We need to calculate height. Solution. Power is equals to work done per unit time, that is equals to mgh divided by t, and putting values of power, mass, g and t, we get h is equals to 400 into 3 divided by 100 into 9.8, and after solving we get height is equals to 1.22 meters. Question. A ball of mass 100 gram is thrown vertically upward at a speed of 25 meters per second. If no energy is lost, determine the height it would reach. If the ball only rises to 25 meters, calculate the work done against air resistance. Also calculate the force of friction. Data. Mass of ball is equals to 100 gram, that is equals to 0.1 kg. Speed of ball is equals to 25 meters per second. We need to calculate height to which the ball would reach, and if height is equals to h steric is equals to 25 meter, then we need to calculate work done when height is 25 meter and force of friction when height is 25 meter. Solution. By ignoring air resistance, we know that loss in kinetic energy is equals to gain in potential energy, because ball is thrown vertically upward, so there is loss in kinetic energy, that is equals to gain in potential energy when we ignore air resistance. And putting formula of kinetic energy half mv square and potential energy mgh, and from here we get h is equals to v squared divided by 2g, because m is cancelled with m, and we get h is equals to v squared divided by 2g, and putting the values of v and g, and after solving we get h is equals to 31.9 meters. If height is equals to 25 meters including air resistance, then we need to calculate work done. So loss in kinetic energy is equals to gain in potential energy plus work done against friction. From this formula we can calculate the work done when we include air resistance. So work done is equals to loss in kinetic energy minus gain in potential energy, and putting the formula of kinetic energy half mv square and gain in potential energy, that is equals to mgh. Here we use h steric for 25 meter of height, and putting all the values, and after solving we get work done is equals to 6.7 joules, and we need to calculate force of friction when height is 25 meters. So work done is equals to force into displacement. Here force is F and displacement is h steric, because that is 25 meter of height, and from here we get force of friction, that is equals to W divided by work done divided by h steric. Putting values of work done and height, we get force of friction is equals to 0.26 Newton. that is equals to 0.3 Newton. Question. An object of mass 1000 gram falls from a height of 30 meter on the sand below. If it penetrates 4 cm into the sand, what opposing force is exerted on it by the sand? Neglect air friction. Data. Mass is equals to 1000 gram, that is equals to 1 kg, 1 kilogram, and height is given, that is equals to 30 meters. Distance through which object penetrate in sand is equals to S is equals to 4 centimeter, and that is equals to 0.04 meter. Opposing force we need to calculate, that is equals to F. Solution. Loss in potential energy is equals to work done. Loss in potential energy is equals to mgh, and work done is equals to F into S. F is force, S is distance, and from here we get force is equals to opposing force is equals to mgh divided by S. Putting values, and after solving we get F is equals to 7350 Newton. Question. A body of mass m drops from bridge into water of the river. The bridge is 10 meter high from the water surface. Find the speed of the body 5 meter above the water surface. Find the speed of the body before it strikes the water. Data. Mass is m. Height of bridge from water is equals to h1 is equals to 10 meters. Initial velocity v1 is equals to 0. Height h2 is equals to 5 meters, and we need to calculate final velocity when height h2 is equals to 5 meters above the water surface, and we need to calculate final velocity at surface of water, that is equal to Vf static. Solution. Gain of kinetic energy is equals to loss of potential energy using the formula half m final velocity square minus half m initial velocity square is equals to loss of potential energy that is equals to mgh1 minus mgh2. We know that initial velocity is equals to 0, so this term becomes equals to 0, and we get half m final velocity square is equals to mg h1 minus h2. M is cancelled with m, and we get final velocity square is equals to 2 into g into h1 minus h2. Taking square root on both the sides, we get final velocity is equals to under root 2g into h1 minus h2. Putting the values, and after solving we get final velocity is equals to 9.9 meter per second. And now we need to calculate final velocity at the surface of water, and that is equals to half m v static square minus half m v initial square is equals to mgh1. Initial velocity is equals to 0, so this term becomes equals to 0, and we get Vf static, that is final velocity at the surface of water, square is equals to 2gh1. Taking square root on both the sides and putting the values, we get Vf static is equals to 14 meter per second. So final velocity at the surface of water is equals to Vf static is equals to 14 meter per second. Question. The engine of a JF Thunder fighter made of Pakistan and China develops a thrust of 3000 Newton. What horsepower does it at velocity of 600 meter per second? Data. Thrust of engine is equals to F is equals to 3000 Newton. Velocity is equals to 800 meter per second, and we need to calculate power in horsepower. Solution. We know that power is dot product of force and velocity, and that is equals to power is equals to Fv cos theta. Putting values of F, velocity and theta, and after solving we get value of power in watts, and we can divide the value of power in watt with 746, and that will give power in horsepower, that is equals to 2413 horsepower. Question. The mass of moon is 1 divided by 80 of mass of earth, and corresponding radius is 1 divided by 4 of the earth. Calculate the escape velocity on the surface of moon. Data. We have mass of moon is equals to mass of earth divided by 80. Radius of moon is equals to radius of earth divided by 4. We need to calculate V moon, escape velocity of moon. Solution, we know that escape velocity of earth is equals to under root 2 gme divided by re, and escape velocity for moon is equals to under root 2 gm sub m, that is mass of moon, divided by rm, that is radius of moon. Here mass of moon is equals to mass of earth divided by 80, and radius of moon is equals to radius of earth divided by 4. And we can separate under root 2 gme divided by re, and we get v escape velocity of moon is equals to under root 1 divided by 80 divided by 1 divided by 4 into under root 2 gme divided by re. This formula is of escape velocity, so we can write under root 2 gme divided by re equals to v escape velocity of earth into under root 1 upon 20, and this term gives us 0.223 into v escape velocity of earth is equals to 11.2 km per second, and we get escape velocity on the surface of moon is equals to 2.5 km per second.